So in this video, I'm going to just discuss the distance approach, how I use distance approach and the number line to solve absolute value problems faster. It is faster than doing it theoretically or algebraically, and I feel that this approach is very misunderstood. It's less understood by many, and we're going to look at the basics of this approach. So how does this distance thing on the number line work? Right? When you say, so let's begin with this example that I've already sketched out. If I say 5, what is the distance? What is the absolute value of 5? The meaning of that is absolute value of 5 represents the distance of the number 5 from 0 on the number line, and how many steps, how many units do we have to walk from 0 to get to 5? 5 steps, and that is what absolute value of 5 represents. That is why when somebody asks you, or the question is, what is absolute value of -5? That represents the distance or the number of steps you have to take on the number line to go from 0 to -5, which is also 5 steps but to the left. And that's why both these absolute values, answer comes out to be 5, which represents the distance of the number that you're asking. The distance, for example, -5, what is the distance of this number from 0 on the number line? Okay, so I'm gonna now, with that understood, we're going to try to use this in an algebraic sense. When a question goes, what is the absolute value of x? The simple way to plot it is that you can do 0, just plot x anywhere, and the distance from 0 to x is absolute value of x. As simple as that. Right? Now, here comes a little bit of fun part. If I do absolute value of x minus 1, okay, on the same number line where you have 0 here, and let's say x is here, where would x minus 1 be? X minus 1 would be one step lesser than x. So we go one step down to reach, my bad. So that gets x minus 1. And the distance of absolute, what is the absolute value of x minus 1? It is the distance between 0 and x minus 1. Great. Now, there's another way to look at it, and that is what we're going to use in the GMAT problems. This distance, what is 0 to x minus 1, can I say that it's the same distance as this, which is absolute value of x? And let's draw a 1. Let's say this is 1 on the number line. So this is 1 unit. Can I say that from 1 to x, this is the distance of x minus 1? Yes, you can. But in this case, like, I'm assuming that x is positive, right? Okay, let's see if it works for x being a negative number. Alright, I'm going to draw this a bit neater. I'm going to draw this x minus 1. Let's assume 0 is here and x is a negative number. Great. So where would x minus 1 would be? It should be somewhere here. X minus 1 becomes even more of a negative number, thereby yielding a bigger distance. Alright. Can I say that this distance is from x to 0 and then to 1? So the distance between x and 1. Aha! These two distances, x, absolute value of x minus 1, works in this case as it does up here. Alright, so in both the cases, whether x was negative or positive, I just saw, and I showed it to you, that x minus 1 is nothing but, it could be looked at as distance between x and 1. And that's the trick we're going to use. Every time, let's say you have x minus y. Okay, how am I going to look at this on the number line? I'm just going to say, okay, let's say 0 is here. I'm going to, it depends on where they want you to put x and y, but let's say that they say the question mentions that x and y are both positive. Sure. So I'm just going to put x here, y here, or something like that, just as a beginning, just to begin the problem. And absolute value of x minus y is nothing but the distance between x and y. So that, my friends, is a nice little trick to start your absolute value problems. How will you use that for absolute value of x plus 2? Now, plus is a bit tricky. Addition is a bit tricky because you don't know whether x is positive or negative, so you don't know whether this is effectively an addition or a subtraction, like the value is going down or up of x plus 2. So I'm going to convert this into, again, x minus y form. This becomes absolute value of x minus negative 2. So if you plot this on the number line, it can look something like this. 0 is here, negative 2 is here, and x is here. X minus negative 2, this is your distance of absolute value of x minus negative 2, or absolute value of x plus 2 would be this fantastic diagram right here. So in other words, you can actually use absolute values in a lot of problems. So let's see how you're going to use this in a given problem, right? That's the ultimate question. So after 6 minutes on the theory, we're going to just quickly see how I'm going to use this in a given question. Let's say that the question is absolute value of x minus 5, I'll make it plus 5, even better, less than absolute value of x plus absolute value of 5. Alright, statement 1 is that x is less than 0. Statement 2 is that x is less than 5. Okay, I don't know, it's just a random question. Okay, so is absolute value of x plus 5 less than absolute value of x plus absolute value of 5? The question really here is asking me is, if x was positive, right, then x and 5 would have the same sign. So these two, the left hand side and the right hand side, would have been equal. The question asking me about less than already means that they are effectively asking me, is x negative? So first statement is sufficient, second statement is not sufficient, A is the answer. You see how this identity really helps you do the question much faster. Let me try to do this not in such a sneaky way, but actually explain it on the number line, right? So let's erase this, erase a little bit of all the calculations I've done. Okay, absolute value of x and absolute value of 5. I have 0 is here, I know 5 is here, I don't know where x is. Let's say the first statement says x is less than 0. X is less than 0 means somewhere here. Now the right hand side is this, absolute value of x. This is absolute value of 5. Fantastic. What would be x plus 5? X plus 5 would be, x plus 5 is nothing but, as we discussed in the last slide, absolute value of x minus negative 5, right? Negative 5 would be somewhere on the negative side, so somewhere, let's say here. The distance from x to negative 5, between x and negative 5, is it the same distance as these two individual distances summed up? No, it is not. So it's always going to be lesser, no matter where negative 5 is. Negative 5 could be here, but it will never be the distance of absolute value of x plus absolute value of 5 all added up together. So it will be lesser if the first statement is sufficient. Let's do the second statement. 0 is here, we know 5 is here, and the question says x is less than 5. Alright, this is slightly tricky, huh? Well, I'm going to just put x1 here to try to get one answer. Okay, and then we'll try to work out the other one. So with this in place, I've got absolute value of x and I've got absolute value of 5. These two sums added up together. Oh, sorry, absolute value of 5 is wrong. Mistake. This is absolute value of 5. If you ever see a mistake in the videos, don't hesitate to comment. Everyone makes mistakes, so it's all good. So the right hand side is the sum of these two numbers. Okay, these two distances. So it is definitely more than 5, right? It can be 7 if x was 2, if it could be 8 if x was 3. Doesn't matter. Let's try the left hand side. Left hand side is the distance between x and -5. Okay, so this is tricky. I don't think that I will be able to tell. In this case, it looks like the distance is always equal, so it's not. Okay, so with x1, I know the answer to the main question. Is the left hand side lesser than right hand side? No. But to prove it insufficient, I will try to just again play with the same trick that I did in the last statement. If you put it something like this, as we did in the previous slide, we will see that the answer comes out to be a yes. So that is a y of the second statement is insufficient. So this was the working for the second statement. It's insufficient, while the first statement was sufficient, and that's why A is the answer.